Okay, so you may have seen something similar to this on YouTube. It shows supercooled water freezing almost instantly. You may have even tried to recreate these effects yourself. Unfortunately, at least in all the videos I've seen, people seem to be depending a lot on luck. They're just throwing lots of water in the freezer for just the right amount of time and hoping to get supercooled water out. I think that with just a little bit of scientific understanding, we can get much more reliable results every time. A lot of insight can come from a very useful tool called a phase diagram. So on a phase diagram, we've got pressure on the y-axis, temperature on the x-axis. And what the phase diagram is telling us is what phase the water wants to be in. Does it want to be a vapor, a liquid, or a solid at a given temperature and pressure? Since most of the things we do here on Earth are at 1 atmosphere, we're very used to operating on this isobar. We're used to, for example, water freezing at 32 degrees Fahrenheit and water boiling at 100 degrees Celsius or 212 degrees Fahrenheit. We can change those boiling and freezing points by changing the pressure, and that helps us a lot in this experiment. Because if we're operating at a higher pressure, we can take a liquid colder than 32 degrees. Then, by releasing the pressure, drop down into the solid region of the phase diagram, instantly freezing. We're going to need some water, and we're going to need a way to pressurize it. And it's better if you get an unopened bottle of water. That way you've got a stronger seal, so when you pressurize it, it doesn't go all over the place. So how are we going to pressure up this bottle of water? These are vice grips. And with this little knob here, you can adjust just how far open these tongs go. So depending on the size of your bottle of water, you can get just the right fit. So in the end, you're going to have something that looks like this. I use the paper towel so it doesn't slip on the plastic bottle as much. And depending on how much pressure you can supply to this bottle, you'll be able to go to a lower and lower temperature and the water will stay a liquid. So I've ratcheted up my vice grips as far as I think it'll let me go. I'm going to stick this in the freezer and see what happens. Just one quick clarification. Where all these lines intersect is known as the triple point. That is at the temperature and pressure that the solid, vapor, and liquid phase can all coexist. Now, that is not 1 atmosphere and 32 degrees Fahrenheit for water. I didn't want anybody to get confused because on my diagram they look pretty close. Water as a solid is actually less dense than it is as a liquid, which is why ice floats. So as we increase pressure, we move from a solid to a liquid phase. For many other materials, the boundary between the liquid and solid phase actually slopes in the other direction. Meaning as we increase pressure, we go from a liquid to a solid. Intuitively, this makes sense, because as we're adding more pressure, we're basically squeezing the matter into a more dense phase. In the case of water, liquid is the more dense phase. Alright, so I've left the water and the vice grips in the freezer for over 4 hours now. The vice grips are pretty cold and unpleasant to hold, but the water is in its liquid form, which is good news for us. Now when you take these vice grips off, you can proceed in any way you'd like. In fact, have fun with it. So here's one thing you can do. I'm going to wipe this off so you can see more clearly. We still got liquid water in there. I'm going to give it a solid bang on the table here and we're going to see what happens. As you see, ice crystals form from the top to the bottom. Now it's not going to be a solid block of ice, but there will be a fair amount of ice in there. So another thing you can do is take the super cold water and pour it into a cold vessel. The cold vessel is going to help seed the nucleation of the super cold water. I'm using my cat's water bowl here. So as I'm pouring, you're going to see this mountain of slushy mass build up here. Pretty sweet.